Literature Review by Enzo Bonelli, Jeremy Sauza, and Wyatt Marciniak. Step 1. Design data scraping API libraries. The goal is to use Python as a web scraper to source data for the design, development, and backtesting of trading algorithms. Reliable literature pertaining to Python web scraping algorithms with respect to stock market analysis and trading algorithms revealed a collection of papers which speak to the viability of Python as a web scraping tool. In summary, the papers cover theory, strategy, and a summarized review of analysis tools and resources for developing and deploying web scrapers as data source tools. Additional papers listed below the main paper review serve as references and complementary resources for our project. They cover different topics across financial markets and economics, utilizing Python for data scraping, varied data sets from multiple sources, detailed design characteristics, issues, and solutions. Collectively, the selected papers document the viability of Python for financial data scraping and processing. Our first article, A Comparative Study on Web Scraping, presents research on the structure of the real-world applications for web scraping data systematically, which covered market, government, and business data. The article introduced commercialized application structures as well as a comparative review across techniques and software options used for development and testing. The methodology is purely research-based and is designed to aggregate information and resource details for a concise overview of web scraping design and potential. The usefulness in this article is the uniform structuring for API, reference lists to top tools for development and testing, and design ideas for scalability and automation. The second article is Strategy and Implementation of Web Mining Tools. The process of scraping is dissected into granular categories: content, structure, and usage, which can be used to direct data collection operations at different levels, from front-end HTML to back-end server logs. Research discusses graphing algorithms as ways to effectively traverse a website's HTML source code to find, search, and potentially mine data from URL links. This traversal continues until all nodes on the graph, which are valid and accessible, are reached, which creates a map of the website, but more importantly, has allowed the scraper to systematically move and collect data. The methodology of this paper is designed for research on algorithms that operate on multiple layers of website data. The separation of data classes to scrape creates potential for an increase in the depth of data collection, but also in the methods the scraper can use. The usefulness of this article is the automated scraping using structured traversals, multi-layered data scraping, more data on usage and statistics for the host than just web page data, and in-depth structural layout of scraping operations, which can be used to model scrapers for automation or targeted data. Article 3. Finance Data Analysis, a comparison between yearly economy change and tone management. Python Web Scraper, which is designed to scrape financial statement data for analysis in a project studying the relationship between tone of voice in public relations, PR, and a company's performance for the year. Research correlating GDP to sentimental value of reports for business recognition standings. This is explained in the issues with scrapers operating pertaining to DDoS, events, and the speed and offered solution designs and useful notes from testing. The methodology, which has created a Python web scraper to collect financial statement data and utilized free public proxy addresses for requests to better mask server traffic while the scraper works, identified a commonly faced problem for web scraping algorithms, and addressed it by making its server traffic appear as if random systems are making calls, which is the ideal solution that replicates normal traffic. The article has pertinence due to the validation of and reference to Python as a working testable source language with documentation. It highlights the issues of DDoS blacklisting with solution designs and reveals a key component needed for the API. The article also shows reliable and repeatable results, a common problem that needs a dynamic solution for scalability. Next, we'll be going over our minor papers, such as Scraping Edgar with Python. This is a good example of financial data being scraped by Python. Appendices contain source code for references, and detailed reference for Edgar data scraping design. The Edgar data scraping design is lacking depth, though, in scraper design details, but architecture of using Python web scrapers to source data for use in driving a trading algorithm is a valuable reference. The second article of minor papers is Stochastic Signal Modeling Techniques for Stock Market Prediction. In this article, the goal is to utilize autocorrelation in order to measure the degree to which the current variable is correlated to the previous values. This is done using autoregressive and autoregressive moving average models, aka AR and ARMA models, to predict the next day's closing price. The AR models the dependence of the variable to be predicted with its own lagged terms. The ARMA model builds upon the AR model through the implementation of a moving average for the inclusion of lagged terms on the residual. AR finds the autocorrelation between the various elements of the time series to calculate the poles. Now the poles are the number of lag terms. Since AR and ARMA models are based on least means squared algorithms, one can use machine learning to predict the output of the system. The article showed the AR2 has the lowest MSE, mean squared error, in comparison with higher orders. Using fewer poles or lag times is more accurate. The ARMA model alleviates the overfitting problem in the AR model. The higher the lag term, i.e. 2, 3, 4, the more overfit the model becomes. In conclusion, the AR model has a lower MSE than the ARMA model, but through visual inference, the ARMA model tracks the peaks and troughs better. It validates our design approach as well as offering design and result data for time series predictions as trading signals. This concludes the presentation. Thank you.